Swayam Prabha. Digital India. Educated India.
So now I am just talking about this certain aspects about the, it need not be just the ADA here, I am just taking one example of ADA, but in any of these languages, okay, whenever they are used. So for example, Java used for banking software, very important that Java also, it should have the similar kind of accuracy, it should be have the similar kind of reliability. You cannot use a Java for writing a banking software if it is not reliable, right? The arithmetic has to be reliable, there obviously the code that is getting executed has to be reliable. So all this basically is an important part, definitely, but beyond that what we need to look at is that the compiler, actually you need not look at the as a single entity, but you need to look at the overall environment. Okay, now let us look at the what is the environment here that is generally, and how these compilers, commercial compilers nowadays, you are using this Eclipse where you are using only the Java JD, you have the what that Java development toolkit exists, then Java then the C development toolkit exists, all those basically are plugins that are available with Eclipse, right? This actually in fact this particular environment that I am talking about, it's in 90s it was developed actually, and it used to provide much more in fact sophisticated ways of overall managing your software, millions of, when you are writing the millions of lines of code, how you can do it, that was existing there. Okay, so what is this particular, how this particular commercial compilers are structured? They are commercial compilers like ADA and all these things, they are structured in a way that you just don't give up one single liner that execute this Java program, okay, or compile this Java program. They don't provide just the command, one command, but what they provide is a compilation environment. That means what they do is that they divide the overall phases of the compiler in such a way that I can utilize that intermediate representation to do certain activities that are required by the during the editing by the developer, correct. So here you can look at that there is a persistent intermediate representation. So what we talked about here till now, that intermediate representation, that AST, abstract syntax tree, first thing, annotated abstract syntax tree, if I just keep it in memory and throw that particular information after the compilation is over, then I am losing lot of things. So the commercial compilers, many of this which provide this particular environment to work on, okay, when you are developing in a team of hundreds, they have the capability, they actually store this particular intermediate representation in a it's a persistent actually, and it is stored in a disk so that it can be used, whenever the team is actually working. For example, I compile one particular Java file, you have class, actually dot class you store, right. That dot class itself can give me certain information which the maybe your Eclipse can use it, okay. Sometimes Eclipse has its own intermediate format, but whatever it is, you can generate a dot class file, you can, before that you can have the intermediate file, and that you can use that information to navigate certain things, right, show usage certain things. Here basically what is done in that is that this persistent intermediate representation, okay, is used, that is a compiler's intermediate representation is used by editor, but it is used by the test tools also. How the test tools use it? They refer to this particular persistent information and they say, okay, this particular I can generate a test case. They automate that particular test case generation. So there are actually test case generators which use this particular information which is there in the abstract syntax tree and generate the test cases. So this environment actually is whatever I am talking about, the software engineering environment and the compiler environment, they come up with a compiler. Definitely you compile, but the compiler actually does not throw away the information that it has gathered. It basically stores that information, keeps it in a as a persistent intermediate representation, and that gets utilized or that can be used by your editor, your during the smart compilation, even by the debugger. Okay, so there will be certain information used by the debugger. All this information is stored, and that is the way these compilers are used basically. The compiler phases the information generated by each phase is used. Are you getting it? Any question here? Any question? So here see this abstract syntax tree, it is good to learn as a part of the Java compilation phases, okay, definitely. But the thing is that you need to look beyond that. How can I utilize this particular analysis done by the compiler? If I store this information, I can use it in a much more effective way. That is what this particular compilation environments do. Whether it is a Microsoft Visual Studio or it is a Eclipse, they have their own intermediate formats. In fact, Microsoft Visual Studio, you will find that somewhere it stores that lot of information actually, okay, and that actually it gets, so where it is generated as a part of your compilation, because you are compiling a program, you are going through the certain phases, you are actually in fact extracting certain information out of this particular program, and this particular is obviously going to be useful for you whenever you are developing in a team, or whether you are individually also developing. You want to see that how many places my particular variable is used or function is used, etc. So look at that angle also, and this persistent intermediate representation. So the IR intermediate representation that we are insisting on and stressing in this particular lecture. For last minute I talked about the initially about the abstract syntax tree as a annotated abstract syntax tree, then we talked about the 3 address code. There is this intermediate representation is a very important actually in this overall compiler backend, and also from the front end perspective also. And not only that, it is also useful whenever you are developing a compilation environment. This intermediate representation in case of ADA kind of languages, it is actually called as a DINA. I will talk about that, but just to give you an idea what happens, how the overall basically our structure, compiler structure changes whenever you are going to the compilation environment. What you do actually is that there is a source file. So there is a source file you edit it, okay, you edit that. What the compilation environment will say, it is now just the archived state actually, it is not really syntax analysis is not done, semantic analysis is not done. So if I do a let us say I want to navigate from there, that where is the definition of the particular variable or particular, it may be difficult. So what this compilation environment do, immediately when you say that I want to navigate it, it will basically parse it, and if it is the parsing is successful, then it basically says that okay, now at least I have collected certain information, let me try to semanticize that, and then it does the semantic analysis on the fly, and this information it is storing also in the your basically intermediate representation, persistent intermediate representation. So whenever you are doing editing, you are actually doing this activity of partial compilation, you are storing this in the intermediate representation, and that intermediate representation gets annotated as on the way, and this particular part, this particular is what is happening in your actual editing and compilation and all this basically loop. So edit, compile, debug, you might have heard that edit, compile, debug loop, right? Edit, compile, you do editing, you compile, you again do editing. So what happens is that while do you do editing, you store certain information in the intermediate representation as a persistent intermediate representation, you compile it, use that information, reduce your compilation time, compile it completely. Now you have complete compilation information that you can use it for the next editing, and then again or the debugging also. So your edit, compile, debug cycle actually is reduced by this overall basically persistent intermediate representation. That is where all these commercial compilers, most of them work actually. In the case of Eclipse, it is a slightly different Java because it is not integrated, but if you use the Altacian and all, maybe it is more integrated, maybe you will find. Okay, now this particular persistent intermediate representation, in the case of very one of the initial ones I will say is a dyna, which is a basically distributed, sometimes it is called a descriptive, but it is a distributed is a right word, distributed intermediate attributed notation for ADA, okay, dyna, and it was also used by the way for the PLSQL, okay, it was also used for PLSQL, where the now you can look at here that I am representing it, this as this becomes a persistent intermediate representation. So obviously the references to the variables has to be in fact, or references to the other units, okay, other classes, other files has to be in fact portable. So this particular is a portable kind of thing, it is a distributed, you can put it on a one particular system and other system also, it is not a problem, you can just actually push it from the 68,000 to or there is no 68K nowadays, but whatever it is, big Indian machine to a little Indian machine, okay, you might have heard about this big Indian, little Indian. So these are portable, these are not binary kind of thing, these are absolutely portable kind of format that was developed. And this particular intermediate format, you have seen that Jimple code in a linear fashion, right, it's a textual format, right. So Jimple code is also portable that way, textual way I can represent it, right. So that's the approach that was taken. I will show you that structure, how it is represented. For example, just to give you an example, before that I need to explain one particular construct, actually language construct, so that I can give an example. For example, we want to see how this dyna is represented, but before that I just will give you one example, that there is a statement in case of ADA which is called as an exit statement. You can exit, there is a break statement in your case, right, in the case of Java and all these things, Java and C. So there is a statement is called as the exit. You can exit and after exit you can give a label name. So you can exit label, so that means you can exit from the multiple fors basically. So you just give a exit here, you can see that here I am saying here exit process request, that means the process request loop is exited. Suppose there is a nested loop, you can specify that also. So here there is an example given here, that there is a exit statement, the syntax for is exit statement, exit loop name which is optional, and there is also when condition can be given, okay. Now this particular kind of statement, I am just taking a simple example, this kind of statement if it appears in your program, how it gets stored, what is the intermediate representation for that? Intermediate representation for that is actually like this is stored on a file ultimately, okay, this is stored on your obviously it also is stored in your memory, but if required you should be able to store in a disk also. The way it is basically represented is that if you look at very interesting part, as I said, intermediate representation in this case can be used by the editor. Now how it can be used by the editor? How it can be if I change, let's say anything, you have any question? You too? Any question? No, you are discussing something, that's why, no, right? Okay. So if you basically are referring to certain things, okay, for example, I have written this particular, we have seen this particular code here, right. In this particular code, I have handwritten this code, correct. Now I want to basically, the way it is written, I should be able to, if this source code is, in fact I lose this source code, I should be able to reconstruct that source code as it is. Why I need that particular facility? There is a pretty printers and all these things are there. There is a format, right? You do the format in case of Eclipse. You select the code and then say format, correct? It formats it on its own, right? But after that, many times have you done that or not? Have you used this format or not? Have you used any time format in Eclipse? No? Yes or no? No? You have not used anytime format, okay. So you should use, so it's a pretty printing actually, very simple. It's basically rearranges your code in a way that it looks more elegant, okay. So this type of basically pretty printing, if you have to do it, then you do the pretty printing and then you modify again yourself to look that particular code more readable. For example, I want this code, this structure of the code to be preserved. Okay. And obviously exit is on the line number 5, sorry 1 2 3 4 5 6, and it may be at a source position, let us say character 5, correct. So this particular information, suppose I say I want to find out that where the exits are used, I should be able to in fact not just the search, but actually do that exit as a statement where it is used. I should be able to point out to the beginning of that exit immediately. Okay. That how can I do that? I need to have that particular information stored in my intermediate representation. I can search fast. I do not want to search the text actually, because text can be that exit can be, then I need to do the lexical analysis again, because exit can appear in a string and all this thing. I do not want to do that. I have already done the lexical analysis. I know that there is a exit statement, and that I want to find out all the exit statement in my code. I should be able to do it in 1 second, 30 seconds or 15 seconds, whatever fastest way, and show that part, rather than doing again the lexical analysis and the syntax analysis and all this thing, correct. So this can be done only if I can store that all that information about that, where it is occurring in my code, what line, what position, etc. So this intermediate representation there, whenever you are this particular DINA kind of intermediate representation, they not only provide you the syntactic information, okay, they not only have the information about the abstract syntax information like AS as a prefix that is shown here, that you can have the exit may be followed by the name optionally or expression when the condition, but they also store the information about the lexical positions. That means where is the source position, where it ends, where is the, what are the comments on that particular line, all that information is stored there. These intermediate representations are not just for generating code, remember that. They are also for other tools to work, like a testing tool or editing tools to work on your intermediate representations. They are much richer. They may not be the final, they may not be used for generating directly the code. You may have the different IR, and there is something called as a different representation of intermediate representation, which is used at the by the backend phases, which generates that from that particular DINA. They generate that IR and then actually generate the object code. But this particular intermediate representation, DINA kind of representation, they persist, they are stored on the disk, they are used by the disk compilation environment to do the all this during the editing. During the editor also updates that if you have a write permission, then the all those basically it is used in the editor. Editor will use it for maybe referring certain things and all this thing. Okay. You can look at that at the last one, that if you look at the last information here that is mentioned in this particular about this exit intermediate representation for exit is a semantic SM. Semantic basically semantically it is occurring within the loop, that information. So if I want to know the enclosing loop for this particular exit, I can immediately say that okay, this is the loop. I do not have to do again a source code analysis, and again I need to do a syntax analysis and a semantic analysis. This information is available with me in my persistent intermediate representation. I can immediately say that okay, this exit is occurring in this loop. This type of compilation environment, there is the code, each procedure may be each 50 lines to 100 lines, the overall million lines of codes are there. And every time if I have to do a compilation, every time I have to do a analysis, it is a very expensive, and that is why this kind of persistent intermediate representation, where the intermediate representation of the initial phases of the compiler are not thrown, they are stored in the disk. They are utilized for smart editing, they are utilized for smarter compilation. Suppose now this is a smarter compilation is very interesting actually in this compiler, that millions of lines of code are there, one particular file is changed, there may be 1000 files get impacted, but out of that which one need to compile, that information is available because this intermediate representation is stored on the disk. Okay. This particular information may not be stored in the way that I am showing you here, but this is for simplification that I am showing you here, that there are multiple this 3 kinds of attributes. There is a fourth type of attribute also that I have not discussed here, but there are 3 main types of attributes. One is a syntactic information, that this particular exit may be followed optionally by name, may be followed expression by, so I have shown you this syntax, right. Exit may be optionally followed by loop, and there may be when condition. This syntactic information is there, obviously that is a normal AST that you have seen, right, earlier also. Jimple also has that AST. There is a lexical positioning and there is a semantic information which talks about the, so I can say that whenever you exit process code, what is a enclosing loop for me, which is the enclosing loop for me, or which loop I am going to exit, immediately I can tell from this information which I am storing. Okay. So just to give you idea about the more about the, I will just stop here about this Dyna and all. I will just give you one more example of this GCC, and GCC basically also has a ADA compiler, and the reason that I am talking about it here is that this particular we talk about this lexical analysis, syntax analysis and all, how complicated they are. Just wanted to highlight that part actually as a, before we close. What's the time? 12. Okay. Before we close, I just want to give you an idea about how complicated they are and how this particular compilers are really becomes complex in, as the language grows, as the usage of that, how basically you want to use that compiler, that also changes actually, and whether it is used for generating the code which will be used or which will be placed in your embedded system, or what is the purpose for which it is being used, depends on that. So for example, this particular GNU ADA compiler is also quite a good compiler, that's and that actually what it does is actually it has, as I mentioned, it has that generic as a one of the intermediate representation, and you generate a Jimple, and that Jimple actually is a, then you use the, once you use the Jimple, then you have a you can use a GCC backend. Okay, normal GCC backend you can use it actually. Okay. Now the thing is that but the initial parts of that compiler are so complex actually that yes, backend is you are reusing from the GCC, but the initial parts of the compiler are really complex because of the language complexity. The overall this particular, let me just give you an idea that even the syntax analysis, we call it a syntax directed many times, the code generation and all, but the syntax itself, maybe somebody was asking me about the different basically passes of the compiler and all this thing, but there are phases, different phases within each particular phase, there are sub phases that exist. For example, in the case of syntax analysis for the GCC, what they do is that obviously they have divided this overall basically compilation process and they have associated that particular compilation process with the way this particular language is in fact specified in the reference manual. Okay. So what they have done is that they have taken, okay, now the reference manual, this language has a ADA language as a package, Java has a class. So I will just look at that class, I will look at this particular class related, how the syntax analysis is done for the class statement and all this thing. So what they do actually is that they in fact they have divided this overall syntax analysis according to the different chapters of that reference manual. Okay. Interpreter and Java virtual bytecode generator also does the same thing, Java C rather to say, does the same thing. They in fact they treat it actually the each chapter wise how basically this syntax analysis is to be in fact done. Okay. And how basically this syntax is influencing the overall different phases of the compiler, that is what they look at. So they design this particular compiler in such a way that overall basically this syntax directed translation is not 100% used but partially used. Okay. Now there are many sub phases that occur there. For example, in case of GCC, apart from they look at the different, as I said, CH2, CH3, CH13, they are basically chapters of the reference manual. They definitely in fact arrange their or design their syntax analysis according to this particular chapters, but they also have different phases. For example, they are saying that okay, if I need to appropriately synchronize the parser after the error has occurred, for example that error has occurred, then what happens is that the parser actually goes for a toss many times, correct. Suppose you have missed one brace, okay, that braces basically one of the curly brackets is missed, then what happens is that the overall parsing gets for a toss. How to recover and how basically to continue, how to synchronize the parsing, there is a one particular subphase of this particular syntax analyzer. So you have to remember that your error recovery is a very important part of this compilers, and how basically you can give maximum errors, you can list down maximum errors in a one particular pass, that is a very important actually. And that is why syntax analysis, though you can write a YAC grammar, but if there is a one particular mistake done in the by the programmer, then how to recover and how to start, that recovery is important. Then there is a some of the things like a sorry, there is I have missed there is a spelling mistake, but anyway. So overall basically tokenization and how basically to handle the tokens, verification of the tokens, and sometimes there is a context to be given for the tokens, okay. The token cannot work, basically tokenization sometimes requires a look ahead, and that actually need to be in fact looked at appropriately by the syntax analyzer. So there are subphases for that. So in brief, this syntax analyzer, semantic analyzer of these languages are really complicated, and you need to really look at not just that syntax analysis is very simple, I write a YAC program and it's done. No, I write a YAC grammar in YAC and generate the parser, it is not like that. Syntax analysis is very complicated that way for this kind of languages, and along with that what other things I need to do it, that also need to be designed appropriately. So all these compilers need to be designed appropriately. It is not just that you understand these phases and you can start writing the compiler. You need to design it appropriately according to the language that you are writing the compiler for. And one last example here, for example, I am not getting into the semantic analysis of how the GCC does and how we used to do it, but just to give you an idea that one of the ways that you can look at, you study the language, right, you study language basically. What do you do when how you study the language, programming language, how you learn the programming language. Now after going through this compiler course, how will you study the programming language, and let me try to understand. How will you study if you are given now, let us say you are being told that okay, you have to do a programming in Go, programming using Go or the new other language, whatever from Altacian or somebody else, I do not know, some other language for Android exists actually. How will you learn the language? So if you have to, in fact you after going through this type of course, your approach for learning a language should improve, in fact you should be able to I have not learned many, I mean I know many, I can read and interpret any language, rather you can write program in any language easily, but how to study these languages is a very important part, and that is what you should be. So whenever you are doing a semantic analysis, this is the in fact the person who is writing a semantic analyzer, type checkers and all, very intelligent person he has to be, he should be able to appropriately correlate the appropriate the syntax and the usage of that particular syntax and the usage of that particular constructs of that language appropriately. So one of the thing that always most of these type checkers, what they do is that they start with for imperative languages, they start with what is the type hierarchy in my language. I want to learn for this language, I am going to write a semantic analysis, I need to understand what is the type hierarchy in this. Why type hierarchy? He is attacking a type hierarchy because he knows that whenever I have an explicit type checking that exists, okay, if there is an implicit also, there is explicit also, whatever it is, overall basically the whole semantic analysis is going to revolve around this particular type system, okay, type hierarchy. So first thing that he does is to understand what is the type hierarchy of this language, what are the different types of this language. In fact, you after going through this particular 3 weeks, you should also learn that what is the way that I can learn the new languages faster. This is one of the important part is that whether it is a functional programming languages or imperative programming languages, imperatives are easier, functional may be slightly different way unless you have learned certain at least one language, but your language, any language you should be able to learn within 15 days to 1 month kind of thing, if the language is not complex and if you take the right approach to learn the language. So, one important part in any of this semantic analysis, what the semantic analysis person does is that he will understand the type hierarchy of that language in that language, and then understand how the expressions evolve around this, how basically the statements use these expressions, how basically this overall type system impacts the overall program writing. Okay. So, this is the way they do it generally. Okay, the last slide and then I will give you exercise. This is a basically there are various attempts that have been done in multiple things, that how to effectively write a compiler, various attempts in effectively writing a compiler. For example, there was a Pascal P code, that Pascal P code is a nowadays you have byte code, so there was a P code that was developed by in 1980s sometime. Okay, and there is a UCSD Pascal was very famous. In fact, UCSD Pascal and the Pascal compilation system was very efficient, and that came as a that used to come on Apple computers also. And then there was a one interesting attempt. If I have a lex and yak, I have a lex and a yak. Lex is for generating the scanner, yak for generating parser. Why not I have some other generators for the rest of the phases? So, there was a CMU project called as the Production Quality Compiler PQCC, where they tried to automate each of these phases so that you have a specification for the AST. There is a something called the IDL that was developed, where you can write a specification for your intermediate representation, and then you can generate that particular, you should be able to generate that particular phase of that compiler of generating the abstract syntax tree. You have the certain transformation, tree transformation, basically tree transformation language, where you specify that how the optimization, how the transformation can be done. Then there is another thing called as a pattern matching kind of approach for code generation, where you specify that particular specification and you should be able to generate a code. Okay. So, this particular PQCC was one of the earlier attempts to automate each phase of the compiler. It was partially successful, not 100%, but yes, it was. Then there was a portable C compiler, which is a very excellent example of how basically you can delay the overall machine dependence, and they actually made available this C compiler available on multiple environments. Because of that, Unix got portable. Unix became portable to 386 to because Unix was written in C, and that actually made Unix more popular. Okay, because this portable C compiler was a very, GNU is a successful, even in India, one of the organization that I worked on, they have the tools for writing the in fact tree, it used to be called as a tree generator, and you can generate the abstract syntax tree and all this thing. I do not want to highlight that name, but anyway. So, there is definitely there are some people who have worked in the PQCC and Pascal P code. They are basically they have in fact developed all these other phases. Okay, to close this session, the idea was to give you overview of the other phases and actually appropriately syncing in, connecting the dots. Okay, you have learned many things, connecting the dots. That is what the idea was, today's idea, today's lecture idea, that okay, you know many phases of this compiler, you know the order sometimes, how this order, how in order it will work, how basically the other parts that you need to consider, other aspects you need to consider. That is what we have seen here. I have given main focus on IR, intermediate representation, and I discussed that more on that. I taken a different approach actually to discuss, because if I go more theoretical then it is a problem, so I took a more example here. So that's a, but you need to know that really important intermediate representation is very important, and that's basically another kind of you can say artifact or overall basically the data structure of in this compiler that actually flows from the initial phase to the end phase, okay, and there may be more than one intermediate representation that may exist. Now to as an exercise I am giving you a one particular in fact I can pass you somebody on this, but you can just note it down also, that there is a markdown. You know about the markdown, some of you know about the markdown. I have given a references, you can refer to this syntax in the blogs and all this thing. You have access right here, internet access, right? Okay. You can look at this particular syntax and semantics, very simple, and you have used it. In fact, you type in WhatsApp many times star and all this thing, right? You write that for making it bold, correct? So this particular markdown actually is an attempt to make a so HTML is for publishing. So to ease your editing, okay, and writing a more without using a very word processor and all, you should be able to type in a very easy way this particular kind of formatting symbols and formatting information. That's what markdown is. So you can look at this markdown syntax, you can look at this markdown overall semantics of that, and write a translator from markdown to HTML. That's basically exercise. You should be able to finish, all of you. Don't try to make a team of maximum 2 or maximum 3, not more than that. If you do it individually, that's great, but not more than 3 people's team. Okay, remember that. Okay, and all of you should be able to finish this particular exercise. I am sure it's a very simple, within 3 hours it can be finished. So this is a markdown to HTML converter. Make sense? This is a very simple, in fact, and there is a, I have also given the reference that where you can read more. It should not take 15 minutes to know about the markdown. It should not take more than 2 hours to maximum 3 hours to write a translator. If you are 3 people team, definitely you can. Read it carefully, I will pass it on. Okay, just 1 minute, I will just finish this particular from my side. Okay, so hope you have enjoyed, and you have finished this, you will finish this exercise. All the best, okay, and let me know once you finish, right? Thank you.